what you guys did with Teacher Cat on Monday. Okay, we're going to start with a recap of exponents. Now, remember, guys, whenever we want to work with exponents, we need to make sure that we have exponents with the same base. Okay. Now, because I already know over here that I've got a 3 and my 3 is a prime number, I know for a fact that I need the other two numbers to also have a base of 3. Now, how can we change 27 to have a base of 3, guys? Anybody? Good, Asbonge, that's it. Awesome. 3, not 3 over 3, 3 to the power of 3. But I know what you're saying. I know what you're saying, Liabona. Good. So this will be 3 to the power of 2x multiplied by 3 to the power of 3. Now remember that x minus 1 was already there. So we need to keep it there. All of this over. What about 9? What do we do about 9, guys? Good. 3 over 2. Beautiful. 3. Now, even I'm saying 3 over 2. 3 to the power of 2. Good. 3 to the power of 2. But all of that is still to the power of 2x plus 2. All right. So what we need to do next here, guys, is we need to multiply this in. Okay. Multiply in, multiply in. All right. And then we'll get 3 to the power of 2x multiplied by 3 to the power of 3x minus 3 over 3 to the power of 4x plus 4. All right, so our next move here, guys, we're going to note that like bases are being multiplied. So we're going to keep the base. What do we do with the exponents, guys? When like bases are being multiplied, what do we do with the exponents? Oh, Asbonge, you are on fire today. That's it, Gideon. That's it, Samuel. We're going to add our exponents. So we're going to end up with 2x plus 3x minus 3 over 3 to the power of 4x plus 4. Right. I'm going to clean this up over here very quickly. I'm going to get 3 to the power of 5x minus 3 over 3 to the power of 4x plus 4. Now, over here, my exponents are being divided. Therefore, I'm going to keep my base. What am I going to do to my exponents? Instead of add, I will. That's it. We will subtract. We will minus. So I'm going to end up with 5x minus 3 minus 4x minus 4. Remember, we're also minusing that positive 4 at the bottom. So it ends up turning into a negative 4 as well. So my final answer would then be 3 to the power of 5x minus 4x will just give me x. So I'll have 3 to the power of x. And then negative 3 minus 4 will give me minus 7. Samuel, I knew you would make that mistake. Don't. Remember, we are also subtracting that 4 from the bottom. So it's going to be negative 3 minus 4. So my final answer will be 3 to the power of x minus 7. Okay. Give me a thumbs up if everything I've just done rings a bell. You've seen it before. You know how to do it. Give me a thumbs up. Excellent. Samuel, I'm not sure what to make of that face. I'm not sure what to make of that face, but okay. Okay. All right. Awesome stuff. All right. I'm going to give you guys 3 minutes to do this question D. Remember, compare like bases, guys. You can write it down quickly. You've got 3 minutes to answer the question. All right. Ah, okay. No worries. That's okay. No worries, Asi. Hello. Amazing to see you again. Oh, I'm glad. I missed you guys too. Except I couldn't express it because I had no voice. Sure, Samuel's already done. Samuel, let's give everybody else some time to catch up. One more minute, guys. Mbali's just like, I finished such a long time ago. She looks so bored. She's just like, oh, ma'am, this is easy. Challenge me, ma'am. Challenge me. I see you. She finished like forever ago and now she's just chilling. I know, my Fury. All right, guys. All right, that's time. If you're not quite done yet, guys, just follow along with us as we go. All right, so we're going to note that our like bases on the top here are a and a. So we're going to have a to the power of, like bases being multiplied, add the exponents, a to the power of 5. And then we're going to look at the b's as well, e and b. That's going to give me b to the power of 7 over, I've got a bracket and an exponent, so I'm going to multiply this into the bracket, and I'm going to end up with a to the power of 6, b to the power of 6, right? And then I know that my like bases are being divided, so I'm going to keep my base a, and I'm going to minus my exponents, top minus bottom. So 5 minus 6 will give me -1, and for b, I'm going to have 7 minus 6, which is b to the power of 1, which is just the same as b. Now, I cannot leave this with a negative exponent. This a to the -1 can't have a negative exponent. So what I'm going to do is I'm going to put it as a fraction, and I'm going to flip this thing. I'm going to take the a, and I'm going to take it to the bottom, and it's going to become a to the power of +1 over here. So my final answer should be b over a. Give me... Give me a thumbs up if you've got this question correct. Amazing. That's it, Ovaya. Well done, Courtney. Well done, Samuel. Excellent, guys. Anna, I don't know what the salt means, but I'll take it. Thanks, Anna. Okay. All right. Okay, let's look at our next type of exponent question. Nicely done, Delaney. Awesome, guys. Okay, so we're going to look, Anna, they will not allow, the question normally says, simplify, leaving your answer with positive exponents. So you must change your negative exponents to positive exponents. Okay, oh, my voice is still fading. Guys, no, this is not it. This is not it. All right. Okay, so as soon as we get to a question like this, guys, where we see a plus or a minus in between. If we see a plus or a minus in between, what we're going to do, guys, is we're going to split and factorize. That's what we're going to do. Split and factorize. Okay. Right, we're going to split and factorize. Now, I want us to split 35. We're going to split 35. But before we split for 35 and think about the many different ways that we can possibly split 35, I want you guys to note that this is 35 to the power of A. Over here, I've got a 5 to the power of A. And over here, I've got a 7 to the power of A. So how do you guys think we can split this 35 that somehow it has two things that I need in it? How can we split 35, guys? Anybody? Somebody? That's it, Asbonge. That's it. Good, Gideon. We can take it and rewrite it as 5 times 7 to the power of A. Now, I want to note something. I'm going to skip a step. Okay, I'm going to skip a step. Right. 35 to the power of A is the same as 5 to the power of A. Well, let me start with 7. Okay. 7 to the power of A times 5 to the power of A. I'm going to explain. Okay, these things are called prime factors. And I know you guys have heard of them before. What this says, guys, is if I have 2 to the power of A multiplied by 3 to the power of A, because these two numbers share an exponent, I can then put them together. I can multiply them together. I can rewrite this as 6 to the power of A. I can do that because they have the same exponent. The same with, if I have 10 to the power of A, I can then take 10 to the power of A and I can split it as 5 to the power of A times 2 to the power of A. There's absolutely nothing wrong with that. It is sound mathematics. You can do this. Okay, that is why I'm then rewriting 35 to the power of A. I'm splitting it as 7 to the power of A times 5 to the power of A. Give me a thumbs up if what I've just said makes sense. Let me know, are we okay with what I've just done? Excellent. All right, so that's the way we're splitting this 35. Okay, that's the way we're splitting it. So I'm going to split it as 7 to the power of A times 5 to the power of A minus, let me just do that, minus 3 times 5 to the power of A. All of this over 2 to the power of 2A times 7 to the power of A minus 3 times 2 to the power of 2A. Now, if I say to you guys that I've got 2x squared minus x, and I asked you guys to factorize for me, how would you factorize? Good. Nzalo, Nzalo. Like just always. HCF. Just I owe you high fives, hugs, rainbows, flowers, everything. HCF first. I love it. We're going to take the HCF out, and my HCF would be x. And I would then have 2x minus 1 left. I hope we're all in agreement. Right. Sure, I'm so impressed. Yo, Ntalo, you just made my whole night. Like, I'm smiling the whole night because you remembered our default setting, HCF. Love it. Good. So now, if we look at the denominator, not the denominator, guys, the numerator. What is my HCF? What is my HCF, guys? What is common? That's it, Gideon. Excellent. 5 to the power of A is my highest common factor. So I'm going to take it out. I'm going to factorize it out. Right, so 5 to the power of A. Now, if I take 5 to the power of A out, what am I going to have left? I'm going to have 7 to the power of A minus 3. Okay. All right. Remember, guys, if you're lost, put your hand up. I'm happy to answer any question. Okay. Let's look at the bottom, guys. Let's look at the bottom. How are we going to factorize the bottom? What do we see? What do we see at the bottom that's common? That's it, Gideon. Very, very well done. Good. And HCF, you guys are catching on, hey? Nzalo was there already. She's already camped out. Yeah, good. Right, we're going to take 2 to the 2a out. And what do I have left if I take 2 to the 2a out? I will have 7 to the power of a minus 3. Okay, now I see something that's common on the top and on the bottom. Right, so I can cancel. Those two things cancel. Then my final answer is going to be 5 to the power of a over 2 to the power of 2a. Now, here's my question, guys. Can I cancel this a with this a over here? Yes or no? Good. Okay, so Gideon and Liabona are saying no. And Asbonga is also saying no. Who can tell me why? Why can we not cancel them? What do we need, guys? In order to compare exponents, what do we need? What do we need? That's it. Beautiful. Good. Good. We need the same base. Who can tell you on fire today? Just killing it. Killing it. Love to see it. Good. Yes, Gideon, they're separated by a division sign, but we cannot compare exponents unless we have same base. Okay, that's what we always want, the same base. All right. Okay, let's look at this next question over here, guys. Let's look at D. Now, I want us to look at the fact that this is 3 to the power of a plus 1. So we're going to start by splitting. We're going to start by splitting it. This is how we're going to split it, guys. We're going to do this. We're going to go 3 to the power of a. Oh, we don't even have to. I'm lying. We don't have to. It's already split for us. It's already split for us. Okay, have a look at the top, guys. What can I see? What do I see on the top? There's a plus. There's definitely a plus here. So, what do I see at the top? Anybody? Who's got an idea? Ah, Asbonge, that's it. Good. I hope everybody else is seeing what Asbonge is seeing. Good. There is, Samuel, absolutely. Are you guys with me here? There's a common factor. 3 to the power of a plus 1 and 3 to the power of a plus 1. Okay. Absolutely, teacher Nels. That's it, the default setting. So we're going to take 3 to the power of a plus 1 out as a common factor. So we're going to get 3 to the power of a plus 1. If I take 3 to the power of a plus 1 out, what do I have left? I'm going to get 4 to the power of a plus 5. Now, let's look at the bottom, guys. Let's look at the bottom. Okay, I'm going to split 4 to the power of 2a. I'm going to split it into 4 to the power of a times 4 to the power of a minus 25. Anybody noticing anything? I've split it. Now I need to factorize. Does anybody see any kind of factorization that we're used to where there's something times itself twice minus something else that can be written as itself twice? Nobody? What kind of factorization are we looking at? Amber, absolutely, absolutely. It's dots. It's dots. That was So well done. And the reason I'm splitting it is so I can see exactly what's going to go into each of my brackets. Okay, I can see what will go into each of my brackets. I know that if I take this and I split it into 2, I'm going to get 4 to the power of a, 4 to the power of a minus and a plus, and then the square root of 25 will be 5 and 5. Do I see anything that's common? Yes, I do. Yes, I do. The 4 to the power of a plus 5 and the 4 to the power of a plus 5 are common. So my final answer will be 3 to the power of a plus 1 over 4 to the power of a minus 5. And I'm going to ask again, guys, can I do this? Can I cancel the a and the a? Absolutely not. And the reason for that is because we do not have the same base. We don't have the same base. Okay. On a scale of 1 to 10, how comfortable are we with exponents? Because I'm guaranteeing you guys, you're going to see exponents again in matric. You're going to see them in grade 11. You're going to see them in matric. If you're not at a 10, if you're not at 100% 10, exponents are nothing but routine procedure. They are the same thing over and over and over and over. The only way we get to a 10 out of 10 is practice. Okay, because we do not change the rules. We're not changing any rules. We are doing the same thing again and again and again. So we just need to practice, guys. Okay, excellent. All right. I'm thinking your marks are pretty okay. I'm seeing a lot of 8s and a lot of 9s and 100s. I'm loving the 100s parts. Excellent stuff. All right. Okay, let's move on to what we were actually going to speak about today, which is trig. All right, and we're going to move a little fast through trigonometry because we want to make sure that we are getting as much out of this section as we want. All right, so when we see right-angled triangles with things called beta or alpha or whatever it is, there are 2 things we need to think of. First, we need to think of SOHCAHTOA. SOHCAHTOA is our friend. Right, so we need to think of sine, cos, and tan, excuse me. And then we also need to think of the cousins. Who remembers the cousins? Who are the cousins, guys? Anybody remember the cousins? That's it. Oh, Leabona on fire, good. There's cosec and sec, good, sec and cot. Beautifully done, guys. Okay, and the way we remember which cousin it goes, which one goes with, we can always look at the information we have, guys. Okay, tan has a T, cot has a T. Therefore, they are cousins. They are reciprocals of each other. If we look at cos, sec looks like cos written backwards. You guys see that? Cos looks like sec written backwards. So these 2 are cousins. And then the only one left will be sine and cosec. These 2 will then be cousins. All right, it's very important that we remember that, guys. Now, if I said to you guys that this is my angle beta over here, do we know what the angle beta is? No, we don't. That's why we name it beta. But they will always ask us to look for 2 things in these kinds of questions. We always need to look at what do I want. Now I'm writing what do I want instead of do I want an angle or do I want a ratio or a side? Okay. Now, when I want an angle, what am I going to do, guys? What do I do if I'm looking for an angle? Who remembers? Nobody? I made a whole thing out of it, guys. I made a whole thing out of it. Yes, CJ, love it. Beautiful. It's called a shift angle. Absolutely. We shift. Okay, we shift. Whenever we want an angle, we click shift. Okay, we click shift. Always, always, always. When we want an angle, click shift. Now, if we want a ratio, we're always going to use SOHCAHTOA. That's when the ratios and the side come in. We always want something over something else. Okay, which is what we're looking for. I know teacher knows they're amazing. Amazing. All right, good. So that's the ratio and that is the side. That's how we're going to get the side. Now, if this is my angle beta, what do we call this side in relation to beta? What do we call that side? That's it, Anna. Amazing. Good. It's the adjacent side. This is the adjacent. And what about that side? Oh, over there. Good. That's the opposite. And this side that is always opposite my right angle triangle is my hypotenuse. Excellent. All right. Before we continue, I want to do this. I want to remind you guys that if I decide that I have another angle theta over here, if I have an angle theta over here, what is this side in relation to theta? Good. That is the adjacent side. Good. In relation to theta, then this becomes the adjacent. That all the way over there becomes the opposite. And the hypotenuse will always just be the hypotenuse. All right. So it's very important that we look at the thing that we're looking for in relation to the one or the other. Okay, I'm going to change this to theta. All right. So I'm then going to say I've got 5, 13, 12. I want you guys to find me. All right. Once you've found all of these, put your favorite emoji in the chat and let's have a conversation. Okay. Find me those 5. True, Mirula, if you knew that I hate spiders with a passion, word. Can't do it. Cannot, could never be me. I do not like spiders at all. They are not my friends. Yes, Queen Jasmine is missing today. Chloe too. Yes, Chloe was also missing. Yes, Hope, fun fact. Mm-hmm. Hope that isn't helping the case. That's not helping the case. All right. Okay, let's talk about these answers on the screen and completely like just segue away from spiders. Absolutely away. All right. Does anybody want to answer these questions for me? I know they're going to go by very quickly. Any volunteers? So you're so cheesy, Anna. Very, very cheesy. No volunteers, guys. Anybody? Okay. All right. To answer the questions, guys. Focus. All right. Let's start with cos of beta. Now I know that cos is adjacent over hypotenuse. So cos of beta will be 12 over 13. Right? Sine of beta will be 5 over 13. Cos of theta will be 5 over 13 as well. Tan of beta will be 5 over 12. And tan of theta will be 12 over 5. All right. Let me know how much you got out of 5 for that section. Let me know in the chat how much we got. Excellent, guys. Beautifully done. Wonderful. Love it. Very nicely done, guys. All right. Okay. I knew this section was going to be easy for you guys. There's no issues here. All right. We're going to talk about trig on a Cartesian plane. Now, remember, guys, when we look at the Cartesian plane, we're not really given a triangle or anything of the sort. We are usually given a coordinate. Let's say, for instance, they call the coordinate P. The point P, which is 6 and 8. Right. Point P is 6 and 8. So if I draw 6 and 8 over here, 6 and 8, right? I can draw that over there. And from here to there, I can draw a line. Right. Who remembers what that line from the origin to the point P is called? What do we call this line? Who remembers? Anybody? I'll give you a hint, guys. It also has something to do with a circle. Yes, that's it. Fancy. Good. R. Good. We call it R for radius. Right. Then I can go from here. Remember, this is my x-axis. This is my y. I can go from here and draw a straight line down, one that creates a perpendicular line with the x-axis. And then I'm going to have an angle theta over here. Now, I know that the distance from here to there will be my x value, which is 6. And then the distance from here to there will be my y value, which is 8. Now, can I then find the value of r, guys? How will I find the value of r? That's it. Good, Gideon. Good, Anna. Good, Samuel. That's it. We would use Pythag, that's it, you Andre. So I'm going to give you guys 1 minute to find me the value of R. Okay, I'm just going to go blow my nose. I will be right back. Excellent stuff, guys. Awesome. All right. So we know that our R is going to equal to 10. We can just do that. The square root of 6 squared plus 8 squared, which is equal to the square root of 36 plus 64. That is equal to the square root of 100, and that is equal to 10. Good. So my R over here is equal to 10. Then from here, guys, they're just going to ask me the same questions that they have all the time. They're just going to ask questions like, what is the cos of theta? Now, we're able to do that because we can see how to find the cos of theta on the diagram. What would the cos of theta be, guys? Look at your drawing. Look at how we've put it on the Cartesian plane. Yes, Samuel.
6/10.
Beautifully done. That's it. It's 6/10. We're not reinventing the wheel here. Okay. Wonderful, wonderful work, Samuel. Well done. Now, remember, guys, that this isn't always going to look like this. Okay. It might not always look like this. They might do this. They might say that our point P lies on this side. The point P is the point 5 and -12. So we then have to take our point P and draw again over there, right? And this time, our angle would be the one, remember guys, this is 0 degrees. So our angle would be the one that goes all the way around. That angle is theta. But it won't make a difference, guys. We're still going to treat our angle theta as this one in the middle. Okay, we're not going to do any different. We're going to treat it as the one in the middle. They both mean the same thing to an extent. And I will explain. Queen Jasmine, hello, Queen Bunny, where have you been?
On a pre-outing celebration for the holiday. I wasn't at home, so I came for last few minutes of the lesson.
Oh, that's so nice. It's so nice to know that even when you're out celebrating, you're still thinking of us. That's awesome. Thank you for joining us. We literally, everybody that was like, something's missing. Where's Jazz?
Well, I'm here. And hello to Miss Nelly as well.
Hi, Queen Jasmine.
How are you doing today?
I'm good, and yourself? So good to have you.
Quite good.
Yes, today.
Thank you.
I know she's busy out there, Teacher Nelly, having goods without us, like she's having party vibes and good food without us. I don't think. You know what I mean? Yeah. See, look in the comments, Jazz. I tell you.
Thank you. Missed you too.
Amazing. It's so great to hear your voice, Jasmine. Awesome stuff. All right, guys. Okay, let's not digress. All right. So remember, guys, we still need to find R. And we know how we can find R. And remember, guys, R is a distance. Will a distance ever be negative? Will I ever get a negative answer for R? No, not at all. Never, ever, ever. R will always be positive. So I want you guys to calculate for R for me, please. Pop your answer for R in the chat when you're ready. Good, excellent. You, Anna and Samuel, are so fast. Well done, Nico. That's it, good. R is equal to 13, good. R is equal to 13. All right, it's just a simple Pythag. It gets quicker as we go along, but it's about the same thing, guys. It's not too deep. All right, good. So now my next question would be, what is sine of, let's not call it theta because the other one is also called theta. Let's call it alpha. What is sine of alpha? Look at the drawing that we have, guys. What is sine of alpha? Remember, this side over here will be 5, and this side over here isn't 12, guys. This axis over here is actually negative 12. So I need you guys to tell me, what would sine of alpha then be? What is sine of alpha? Think about it. Sine would be opposite over hypotenuse, or y over r. Ooh, it won't be 5. That's it. Good. No worries, Samuel. Good, Nico. That's it, Asbonge. That's it, Anna. Good. It's negative 12 over 13. All right. Let's explore this question down here. Okay. It says here, S, which is -3 and -4, is a point on the Cartesian plane such that OS makes an angle theta with the positive axis. They've even drawn in the theta for us. But remember, guys, no need to panic. We're just going to use this tiny little bit over here as theta, right? Then I'm going to take my point S and I'm going to draw it like that. Right angle triangle. I know that my X value will be -3 and the Y value will be -4. And Delaney, did we use Pythag? Yes, we did. Okay, everybody just did it really quickly. If you have a look, I'm just gonna go back 1 second. Everybody, you've got 5 seconds. Have a look here, Delaney. R would be equal to the square root of 5 squared plus -12 squared. Okay, if you put that into your calculator, you're gonna get 13 out. All right, Tyra, did that help? That was your 5 seconds. All right. Okay, we're going to keep moving, guys. Let's go. All right. It says here, you're very welcome, Delaney. Find the length of OS. Now we know that OS is the radius. And how do we find the radius, guys? We use Pythag. Right. So to find OS, say OS is equal to the square root of my X value, -3 all squared plus -4 all squared. That's the same as the square root of 9 plus 16. That's the square root of 25. Therefore, OS is equal to 5. Okay. Good. Now it says here, we need to find the value of sec theta plus sine squared theta. Right, sec theta plus sine squared theta. What do we know about sec, guys? What do we know about sec theta? Who's this duty? Where does sec come from? Good. It's the cousin of cos. Good. It's cos's long lost cousin. Right. Now remember, guys, cos of theta is adjacent over hypotenuse. Sec of theta would then be hypotenuse over adjacent. Okay. So when we think of sec of theta, all you need to do is look for sec theta. As Bonge, that's very funny. It's from quite an old paper. So your teacher's recycling. Okay, then be very careful, guys. Have a look at this question down here. After sec of theta, it says sine squared theta. It says sine squared theta. So we need to find the ratio of sine theta and then square it. All right. R is equal to 5. Okay, give me an answer, guys. Remember, it says without using a calculator. So if you give me a decimal, 0, something, something, I can already tell this one is a lie. Okay. I'll give you guys 2 minutes. Wonderful, Nico. Very nicely done. All right, guys, let's look at the answer for this question. All right, so I know that sec of theta is going to be hypotenuse over adjacent. So that's going to be 5 over my adjacent, or my x will be -3, plus sine of theta will be -4/5. But I know that this whole thing needs to be squared because it's sine squared theta. So we're going to end up with 5 over -3 plus 16 over 25. And now, because I've got fractions, I know that I need to find an LCD. Okay, I need to find an LCD. The LCD between -3 and 25 is -75. -75. All right. So I then know that I need -75 everywhere. So -75 plus something over -75. I've already got -3. So I know I need to multiply the top by 25. Now, 25 times 5 is going to give me 125. Right? And then I need to take 16. Okay, the 25 is missing the negative, so I need to take 16 multiplied by -3 will give me -48. Okay, so my final answer at the top, 125 minus 48 will give me 77 over -75, which is the same thing as -77 over 75. It doesn't matter where the negative is sitting, as long as there's a negative in the answer. That is the correct answer we will get. Okay, so nothing strange here, guys. Tell me on a scale of 1 to 10, how comfortable are we with doing these kinds of questions? Excellent, Courtney. Love to hear it. Nice, Sandakhe. Sandakhe, good. More than 10. Like that. Nice one, Anna. Good, Hope. Just a little bit more practice, Hope, and we'll get to that 10. Haniso says, well. Well, what? Good, Asi. Trust me, it all takes practice. Okay. It takes practice. Excellent, guys. Awesome, awesome, awesome. All right. The last thing we're going to do for today is calculator skills. Okay. Which literally, guys, just pick up a calculator. Make sure that your calculator is in degrees. Make sure that your calculator is in degrees. And all you're going to do, guys, is you're just going to practice putting the numbers into your calculator. Sine 50, close brackets. Remember to close bracket. Okay. Thank you, teacher knows. Actually, the number next to DEG, yeah, I was about to say the number next to DEG. So make sure that that little D at the top of your calculator is colored in at the top of the screen on your calculator. Okay, make sure that the D is visible because you need to calculate in degrees. Yes, Anna, to 2 decimal places. Okay, it's just basic calculator work. Thank you. Asbonga's got our first answer for us, guys. Let's make this a fire round. Keep going, guys. What about B? What would we get for B? Good. 0.77. I'm looking at this first answer. Asbonga, are you sure about this 5.36? Maybe let's have a look at that one again, because I'm sure it should be a number smaller than 1. It's also 0.77. How? 0.77. All right. What about 10 of 50, guys? 10 of 50 is? (1,19). I agree with you, Anna. Good. That's it, Gideon. Excellent, Sandakache. All right. Sine of 40. Let's look at sine of 40, guys. Good, Samuel. Excellent. 0.64. No worries. We're here to make mistakes. Don't shy away from mistakes. What is cos of 50? I can tell you now, cos of 50 is also going to be 0.64. That's it. And tan of 40. (0.84). Very nicely done. Remember to round up, Samuel. 0.84. All right. All right, guys. Okay, that's the end of today's lesson.